2.3, we are going to talk about only the product rule today. It shouldn't take us too long, and I'm going to give you guys some time to work. So the product rule says this. Now, let me explain what I'm doing here first. I taught you guys some shortcuts to find the derivative rather than using that limit as the change in x approaches 0. Okay. Now, these are more shortcuts. This shortcut is called the product rule. Sometimes you will notice that it just makes more sense just to actually multiply it through. So, like for example, in this first example that I'm going to give you in just a second, you could just multiply the two polynomials, get an answer, and then find the derivative of the answer. That certainly in some instances will make more sense. But there are times when you can't do that, and so it makes sense to use the product rule. Okay, so I'm going to say that because some of you are probably thinking, why are we doing this if I could just multiply it and find the derivative using the shortcuts that I taught you earlier this week. So, all right, so the product rule says this. If you have some function that happens to be the product of two functions, so in this case f of x and g of x, then the derivative of the function is this. This is what you guys need to know. You take f of x, the first function that's listed, f of x, and you multiply it by the derivative of the second function, in this case g of x. And then you add it to the second function, g of x, multiplied by the derivative of the first function, the product rule. So it's f of x times the derivative of g of x plus g of x times the derivative of f of x. It's really not that bad. It's the same thing twice, except in this first one, you're finding the derivative of g. In the second one, you're finding the derivative of f. Okay. So let's apply that to an example. I wrote the first example out for you, and then we're going to work through the other ones together. So first example, 4x squared plus 3x plus 2 multiplied by 3x minus 7. So what I did was I took the first polynomial. In this case, this would be f of x, and then this one would be g of x. And according to the product rule, you take f of x, which is this thing right here, and you multiply it by the derivative of g of x. What's the derivative of 3x minus 7? 3. It's 3. So this right here is the derivative of g of x. You add it to g of x, which is 3x minus 7, and you multiply that by the derivative of f of x. What is the derivative of f of x? 4x squared is going to be 8x. The derivative of 3x is 3. And what is the derivative of 2? 0. So that's why it's just 8x plus 3. So this was the derivative of f of x. Now what you need to do is clean it up. So you're going to take 3 and distribute it into the 4x squared, into the 3x, and into the 2, giving you 12x squared plus 9x plus 6. Are you okay with that?
No.
Probably not a big deal. Plus, now we need to FOIL these two. And when you FOIL them, 3x times 8x is 24x squared. 3x times 3 is 9x. Negative 7 times 8x is negative 56x. And negative 7 times 3 is negative 21. All right, so we have this huge long string of numbers. You collect like terms. We have a 12x squared and a 24x squared together giving me 36x squared. You have a 9x, another 9x, and a negative 56x. You combine those, they get you negative 38x. And then you have a 6 and a minus 21 that combine to give you negative 15. You okay with that?
Yeah. This seems more complicated.
More complicated than what? Now remember, this process right here was it probably would have been easier in this case to just multiply these. Multiply them and find the derivative. So why am I doing this? I want you to understand the process because later, in fact today, we'll get to some examples where you need the process. You can't just distribute or just multiply them. Okay, is that what you were going to ask me? Oh, what were you going to say? Okay. All right, so the derivative of that long h of x is 3x squared minus 38x minus 15. Okay. Try this one together. equals x squared plus 3x times 5x minus 4. So, according to the product rule, you need to take this first function, called f of x. Can I wait just a second?
So we can write the problem.
And this is g of x. According to the product rule, you need to take f of x, which is x squared plus 3x, and multiply it by the derivative of g of x. What's the derivative of 5x minus 4? 5. Yeah, so it's times 5. And you add it to g of x, which is 5x minus 4, multiplied by the derivative of the first function, which is 2x plus 3. I'm doing all of that in my head, but you seem to be okay with that. Tell me if you don't know where I came up with 2x plus 3. I would be happy to tell you.
You got it.
All right, clean it up now. So I'm going to distribute the 5 into x squared and 3x. That gets you 5x squared plus 15x plus, we're going to FOIL these. So we have 5x and 2x is going to get you 10x squared. 5x and 3 multiplied get you 15x. Negative 4 times 2 is negative 8x. And then negative 4 times 3 is minus 12. And then you just clean it up. So we have a 5x squared and a 10x squared giving you 15x squared. I'm going to cross them off as I go. We have a 15x plus 15x, that's 30, minus 8 is 22, so we have a 22x, and then we have a minus 12 at the end. So the derivative of that thing is this. And you certainly could have just FOILed it to begin with and found the derivative that way, okay? But in a second, soon, like right now, it might make more sense to know the product rule. The last example probably not completely necessary. All right. G of x is equal to the square root of x times x cubed plus 6. So, the product rule says that you take the first function, which in this case is square root of x, and you multiply it by the derivative of x cubed plus 6. So I have the square root of x that has to be multiplied by the derivative of g of x, which would be 3x squared. Very nice. Plus, now we take the second function, g of x, x cubed plus 6, and we multiply it by the derivative of the square root of x. So I'm going to come over here. The square root of x really means x to the 1/2 power. So the derivative of that is going to be 1/2 x to the negative 1/2 power. You okay with that?
Mm-hmm.
All right. So times 1/2 x to the negative 1/2 power. Now, sometimes your answers are going to look horrendous, like this, but that's how you're going to have to leave your answer. Because what else can you do to this? I mean, you could clean it up a little bit. You could get rid of the parentheses here. You could say that this is equal to 3 the square root of x times x squared. You okay with that?
Mm-hmm.
Plus, here we've got 1, we gotta get rid of the negative here. 1 over 2 the square root of x. Still okay? I'm just writing these in the opposite order. Times x cubed plus 6. In that case, I would say you could keep going if you wanted to, but I would say you don't have to. You can leave it just like that. Yes?
So we can leave it like with the first one, right? Or do you want it like the second one?
I'm okay with it looking like the first one, except do not leave me a negative exponent.
Okay.
Okay? You could leave this part as 1 over 2x to the 1/2 power. Okay? or the square root of x, whatever case you prefer. Questions? Alright, let's try one more example, and then I'm gonna stop. I had to throw a sine of x in your, or a, a trig function in here. You'll get asked how to do those, so. Alright, so the derivative of f of x. Okay, now, first of all, we need to make sure that we understand what the first function and the second function are. 4x cubed is f of x. The sine of x is g of x. So, we take the first function, 4x cubed, and we multiply it by the derivative of the second function. What is the derivative of the second function?
Cosine.
Cosine of x, yep. Plus the second function, sine of x, times the derivative of the first function, so 12x squared.
Can you just change the sign of x right
Oh, I did, why did I not do that? Oh no, I shouldn't have done that. What do you mean?
now? Oh, never mind.
Yeah, okay. I saw that and I went, oh, I forgot to, but I wasn't supposed to. It's the derivative here, not here. Okay. All right, now, you certainly could do more with this. This is one term. This is one term. What do they have in common? Well, they have more than an x in common.
4x squared.
They each are divisible by 4, and they each are divisible by, they each have at least have an x squared. So if I factor a 4x squared out of this, what do I have left? An x and cosine of x plus, if I divide a 4x squared out of this, what do I have? A 3 and a sine of x. So I'm sure some of you are thinking right now, can we leave it like this? I would say at this point, yes, you could leave it like this. When we get more into this, you might have to start simplifying things more. But either of these answers would be okay. This probably would be preferred. Cleaning it up a little bit.